Welcome and thank you for joining us for another segment of the Jane Irrigation Training Series. I'm Richard Restuccia, Vice President of Water Management Solutions, and I'm really excited today to be delving into part two of our controlled environment agriculture session with Hawthorne Gardening Company. You know, if you were there last week, we learned a lot about design and how these systems are designed and set up. And if you missed it, you can always check our website for part one. Just search controlled environment agriculture and you will find that. And today we're coming back now with our friends from Hawthorne, and we're going to talk about actual system management in controlled environment agriculture, right? This is kind of the next step. And I always worry a little bit about this because I felt like, well, last week I learned enough to maybe be dangerous. So now to kind of follow that up with some more detail, I'm really excited about. And again, you know, we've got great partners here today. Dr. Knight is back, and Patrick Wild, and Shay Donald. And you know, the thing that I really appreciated about last week, for those of you who saw or didn't see, you know, the level of detail was really good and really interesting. You guys just didn't gloss over, right? It was great to see the setup in a way that we came away as viewers of one, having a pretty good idea of what we needed to do. Two, we had a good knowledge of additional questions we had to ask with the setup, and you guys were great for that. So I want to say thank you again for that. And look, I'll turn it over to Shay now, and we can get started. Shay.
Awesome, thanks, Richard. Yeah, we're really happy to be back and excited to have this opportunity. So thanks again, and thanks for the warm introduction. So a little bit of background for Hawthorne Gardening Company. We are a wholly owned subsidiary of Scott's Miracle-Gro. It is their branch into the indoor growing and controlled environment agriculture industry. We are a manufacturer and distributor of many different goods that go into these spaces. So a lot of them that we manufacture, you know, lighting, nutrients, growing media, that sort of a thing. But then some that we distribute, we partner with companies like Jane so that we know that we're getting some of the best products into the space possible. So part of that commitment and the team that I'm a part of, and Rebecca and Patrick as well, is technical services. And what that does is we're there to provide support for the commercial side of the business, be it growers, end users, that sort of a thing. We help with design on the front end to make sure that everything is spec'd out properly. But then we come in afterwards to make sure that everything is then being managed properly. So that's what we're going to be speaking about this week. So Dr. Rebecca Knight, she is the manager of the design team in tech services. She has a background in biology and engineering and is one of the newer members of the Hawthorne team, and we're very excited to have her on board. Patrick Wild is a design engineer who specializes in HVAC, airflow, environmental management, and how all of that relates to crop production. So if you want to talk about humidity, he's your guy. But, and what I do, I've got a background in greenhouse horticulture, and now a lot of my focus is on irrigation design as well as irrigation management in indoor spaces, and bringing a lot of that horticultural knowledge into specifically the cannabis space, which is a lot of fun. So Rebecca will be speaking, kind of diving deeper into what I was just talking about, the management and controlled environment agriculture. Then she's going to speak more in depth on specifically light management in this space. Then I will talk about irrigation management and some of the common issues that we see. And finally, Patrick will tie that off with HVAC management. Again, all this building off of an aspect of last week, which if you didn't see it, that's fine. It's still going to be a lot of fun. So now I'm going to hand it off to Rebecca, and she'll take it from here. Thanks.
Thank you, Shay. So last week we talked about a holistic approach when it comes to controlled environment agriculture, and we were really talking about the most important step, and that is the design step. We've thought about what are different types of controlled environment agricultural situations, whether it's an indoor farm, a commercial greenhouse, maybe a tent, or something kind of unique like you see in the top right-hand side. But they all have something in common, and that is that all these systems come together, they integrate, and they affect one another. So right here we have sort of the physical systems that we're going to be talking about today: lighting, irrigation, HVAC, airflow management, and benching. Of course, there's also other systems such as the nutrients and grow media, for example, but we're really focusing on the physical systems. And today we're really going to dive deeper into effective operation and management of those systems, keeping in mind that they still all interconnect and affect one another. So the first topic I want to cover is lighting. And last week we took a look at lighting. And on my screen, let's see if we could go to the next slide. There we go. We talked about photons. We talked about photons and how in controlled environment agriculture, one of the most awesome aspects is we get to select the light that we want. We get to use light that is necessary for plants. And so I want to talk a little bit about photons, dive a little deeper into this. I like to compare photons. I like to use the analogy of drops of rain. So photons, although it's a little tricky, they don't actually have a mass, but they are considered particles. So we're just going to call them particles for now. So let's imagine these particles of rain, let's say, hitting the leaf surface. So what's important about that? Well, if you go to a store and you shop for lights for your home, you'll often see units such as lumens, or maybe you've done measurements to see what the light levels are. You've looked at the lux. Those are related to our human biases in terms of light. So why don't we want to use that when it comes to horticulture lighting? Well, it kind of boils down to this next image here. We showed this image last week because we wanted to describe that really important critical step, and that is when energy is transferred down into the photosystem of the leaf and it reacts with water. That energy is the very first chemical reaction that occurs in photosynthesis. All reactions after that are downstream. So that reaction, which requires water, has a known number of photons that are necessary for it. And the photons that reach that center, as long as they're within that photosynthetic range, they're all considered relatively equal. So in other words, when it comes to photosynthesis, it's not about the biases of our eyes or how we perceive light. It's all about the quantum. It's about the number of photons that make it onto the plant. So we really care about how many photons are reaching a particular surface over time. So as a fun exercise, let's try to imagine how many photons might be hitting an area over time. And for that, we can look at, for example, if we click to, there we go, the photons needed, I think there may be a lag, the photons needed per square meter per second. And so once again, we really care about the quantum number that are hitting a certain area per second. You could think of it as rain, okay? So let's see what the actual number is for a crop like lettuce. Well, it turns out that lettuce, and I looked this up, this is a quintillion. So lettuce requires around 90 quintillion photons. That's a lot of photons. And so photobiologists, rather than describing that many photons for lettuce, or maybe it's 120 quintillion for tomato, instead we start off by using a common conversion factors that people use when it comes to particles, and that is to use Avogadro's number. So we convert this into moles of photons. That gives us a more manageable number, but it's a little bit small. And so we do one more conversion, and that brings us to micromoles photons. So we can say lettuce requires around 150 micromoles photons per meter squared per second. That term, by the way, is called the PPFD. That's the photosynthetic photon flux density. And last week we brought up the term DLI, daily light integral. We talked about how that is a value that factors in how much light, so the intensity of light, as well as how long it's exposed to light in terms of the photoperiod. But also we talked about how each crop has its own specific DLI requirement over the course of a day. So this would be your intensity of light. It's how many photons are hitting a square meter per second. And then I also want to mention that these types of numbers are available different websites. This is a link to the Ohio State University, which is just down the road from Scott's Miracle Grow. And you'll find other information through land-grant universities as well as ag extension offices. So definitely a lot of information out there. Also want to mention that it's really important to be able to measure light. And there are several light meters out there that will give you the results in micromoles per meter squared per second. Hawthorne has a couple different options, but you'll find many different options out there. So I highly recommend, if you're growing indoors, to pick up a meter and be able to actually measure the light levels in your grow environment and keep track of them over time as well.
So Dr. Knight, I have a question about this. I have actually many questions, and I just want to remind everybody too, they can type their questions into the Q&A, and I'll pass those on to Dr. Knight, or into the Zoom webinar chat, and I'll filter those in as well. So my question is this: we hear a lot about filtered sunlight, right? Hoop houses sometimes have a filtered sunlight. Some people think that grapes do better in the Napa Valley because of the fog and the filtered sunlight. Is there anything to this, in your opinion?
Well, by filtered sunlight, I'm assuming what it's doing is taking some photons out of the equation. So in the case of sunlight, we're going to have a very broad spectrum. Electromagnetic radiation is actually coming in all the way from, UV, past UV to radio waves, past visible spectrum to radio waves, and so on. So having a filter implies that it's taking out some of that electromagnetic radiation. But as long as you get within that range, for example, the range I show here, which is based on kind of a general, it's called the McCree diagram. It's sort of a general absorbent spectrum of land plants. Then you should be good. That is the range that plants respond to for photosynthesis. But always make sure, if you can, try to pick up a device, try to understand what the actual number of photons are. It's really important when we're talking about plants, and it has to do with photosynthesis. It has to do with the reactions of photosynthesis.
Right, so this is like a light meter or something to measure it. It's probably $100, $200.
It ranges. Yeah, it ranges. I think maybe on the low end around 100. It can go up, but this will make sure that you're able to apply the maximum amount of light or ideal amount of light for your crops. That those requirements do change over time, over the developmental stage of the plant, and so it's nice to be able to adjust your light levels as needed. And you can also determine and make sure that you're getting the appropriate photoperiod and DLI for the crop that you're growing. So it is good to have a light meter.
Yeah. Okay, great. Thank you.
Sure. So another topic we brought up last week has to do with different technology that's available when it comes to light and light fixtures. In this case, I want to talk about form versus function. So the very top, you'll see that's the fluorescent light. In the middle, we have an HID, high intensity discharge light. And at the bottom, we have one of our LED fixtures, one of our solid state technology fixtures. In this example that I'm showing right here, this is often called a sea of green, or it's an open room with oftentimes the benches would be towards the center of the room. And it's plants growing out in the open. In this case, you probably wouldn't want the fluorescent type light. It doesn't really put out enough light, but the HID lamp would work fantastic, and so would an LED fixture such as the 1700E that I'm showing there. Now in this next example, we're looking at a greenhouse. Now in this case, you'll notice that there's scaffolding, and although LED technology is fantastic, this particular form factor would not be ideal, and that's because it would block some of the sunlight coming into the greenhouse. In this case, an HID lamp or a fixture, we do have LED lamps that are LED fixtures that have a more linear form factor, but something like that would be more suited for a greenhouse application. And in the third example, this is showing the space saver racking system. And in this example, you wouldn't want to put something like an HID lamp in there. It's just too bright, and it also puts off some heat, and so that would be too close to the plants in this example. So here you can see we've put in that LED fixture. You could also use fluorescent lights in this application. So diving a little deeper, you can see how these fixtures played a different role, and definitely really important when we consider the application for each fixture that we choose. Are there any questions on this?
Yeah, so it's interesting, right? The plant and the building or the facility really dictate what's the best lighting for you. And, you know, people probably need a little help in deciding this, right? Can they reach out to people at Hawthorne and ask this question and get some help? Is that a possibility?
Absolutely. Yes, absolutely. So our technical sales team is incredible. Our sales folks know a lot about this, and they can help guide the customer. In addition, when it gets to the design team, when we get the design intake, we look at it, and we will often offer alternatives. So we might offer 2 different options, and that's a great thing for the growers because sometimes they prefer one over another. Maybe they want to reuse those lights in another way, so they might prefer one type of fixture over another. But there are different aspects and properties for each of our fixtures, and so it's really important to work with when you're designing out your controlled environment agricultural cultivation center. It's important to work with people that can help you pick the best fixture for that application.
Okay, great, thank you.
Finally, I would like to bring up the topic of microalgae. So I love microalgae, and I'll tell you why. I used it in my research. They grow really fast, and you can do some photosynthesis research when you're looking at gene expression under different lighting. However, why are they not so great in a controlled environment agricultural facility? Well, a couple reasons. So for one, algae grow anywhere there is moisture, a tiny bit of nutrients, and light. And that can be on the surface of things. It could be in liquid itself. There's more microalgae species than all animals and all land plants combined. They are an enormous class of organisms. And so microalgae can be a real problem. They can grow in any environment. You'll find them in the most acidic lakes and hottest sea vents, in snow, and so on. So they can be a real problem. And what growers need to do is they need to make sure as much as possible that they don't have pools of water that are exposed to light. They also need to make sure all the tubing is completely darkened, or that they're not using translucent tubing. It's definitely a major issue. Now, when I've done my own at-home gardens, you know, I can usually handle it. I can clean off my equipment, but could you imagine the image that I just showed with all of those trays and all of those potential spots for microalgae growth? Here's from my own grow experiments. You can see, if you look closely, microalgae is growing on the surface of the grow media of the grow plug that I'm using there. And you can see there in my foam flotation that I use to put my grow plugs in, you can see I tried to scrub it clean, but microalgae, it tends to, it's pervasive, and it's just every time I did a new cycle, I'd have to clean it off. At the bottom, you can see there, I was using a particular light for that experiment that made the plants look gray, but they're actually green, and there's green microalgae along the edges of the float. So microalgae is definitely an issue. The larger scale the operation, the more it can become a major nuisance, clogging irrigation lines and consuming nutrients. So it's not the only microorganism that we have to watch out for. And Shay is now going to talk about more of that, as well as get into more irrigation management.
I have a couple of questions first, Shay, if that's okay. Dr. Knight, I'm glad you mentioned that about the color of the lettuce. I thought that was a different variety I hadn't had for lunch yet, so thank you. So if you start to have a microalgae problem, it sounds like you're swapping everything out. You really can't go back and fix this, is that right?
You are having to, if possible, in between growth cycles, you might need to sterilize everything and just try to prevent it better in the future. Microalgae is everywhere. It's in the air. It's really hard to keep it out. So I think the best thing you can do is just try to make sure to minimize exposure of light onto any of your grow media. I should mention, in the case of the grow plug, I was doing an experiment where I had added media, and that's why I had so much algae growing. But sometimes you wouldn't need to do that. So just as best you can, try to minimize exposing light to any of your nutrient solutions. And if you do get an outbreak, you'll have to clean it and try to sterilize it, and then prevent it in the future.
Yeah. Okay, great. And then we've got two people asking kind of a similar question. One wants to know basically the average size of the projects you guys work on, and somebody else wants to know the biggest that you've worked on. So a couple of questions there for you.
Oh, those are great questions. So I'll invite Patrick and Shay to jump in. I've been with the company now for about 2.5 months. It feels like longer because I really, really love my team. I love this company. It's just a wonderful environment. But I'd say for the projects that I've worked on in that time, they've ranged in sizes from a small, almost hobby grower scenario that we helped build out to, let's see, the largest one, I recently did one with 22 rooms. And each room, I want to say, oh boy, maybe 50 feet by 50 feet, something like that. So pretty large, but I mean, they get larger than that. And greenhouses are increasing in size, especially with intelligent greenhouses and intelligent greenhouse design. It's pretty amazing. So I can expect we've worked on even larger projects than that. And I can expect many larger projects in the future as well.
Yeah, to build off that, we, excuse me, up in Canada, obviously we have a lot of greenhouse infrastructure that's been kind of retrofitted with cannabis. And I think some of the larger greenhouses that we have worked with, maybe not so much on the design front, although there have been designs done, but like nutrition, that sort of a thing, it's up to 2 million square feet. So like multi-acre operations, and some of the largest ones in the world, we have strong relationships with.
Yeah, that's great. I was, familiar with one of the ones you guys did in Ohio with us. That was a former beer distributorship that was converted, and I know that was decent size. Patrick, have you seen some large opportunities as well?
Yes, so we have to do custom sizing for bench layouts once a room is in excess of 200 feet in one of the dimensions. So in the past couple of months, we've had a couple of those come through me personally. But I know that other people deal with projects that are just as large as well.
Yeah. So it sounds like it's pretty much like conventional agriculture. You've got the really small hobby farmers right up to the bigger corporate entities. So and big ag. So it's kind of interesting. Yeah. Thank you. Okay. I think we're on to you, Shay.
Okie doke. All right. So another kind of microorganism, gnarly thing that we have to deal with, which I think many irrigation folks might be familiar with already, is biofilm. And this is something that has become an increasingly large problem as growers shift towards more automated irrigation systems. And so just for those that don't know what it is, biofilm occurs on the inside of I think every irrigation system at some point. It's a accumulation of different microorganisms that starts off as kind of a film that sticks to the pipe and then starts to grow and grow and grow. And then it becomes these colonies of a bunch of different species, and it can be very, very nasty stuff, as you can see here. Like these images were taken at a site that we were working with. They were not aware that of biofilm at all, and then of course we got to take some really tasty photos of that. So one of the main contributors to this is this nutrient-rich solution that's sitting in the lines, and then it sits in a nice warm room for a little while, and then obviously that starts to proliferate a lot of microorganisms, especially in cannabis growing, where there are a lot of organic-based additives that are put in there, so you get a carbon-nitrogen ratio kind of thing going on, and once you get both of those components in there, then you're going to just have all sorts of things start growing. So management techniques that we recommend for this include, I mean, the most common one is going to be the injection of chemicals such as ozone, hypochlorous acid, and chlorine. They're very common. And you can have generators that produce ozone and hypochlorous acid in line, or you can add them as a liquid or solid or whichever for chlorine and others. But there are also management techniques that need to take place in order to prevent clogging, because that's the main negative thing here. You know, these chunks will break off and then they end up in your emitters, and now you're having a bad time. So we recommend flushing the lines after each irrigation event, if possible. If you have really bad biofilm issues, get some nice clear water in there, and hopefully it reduces this growth. And on top of that, it's, you know, proper filtration. A lot of these facilities and a lot of growers switched over to a drip irrigation system, but weren't aware of the requirements for some of the filtration that's needed. So a well-designed irrigation system, as well as a regular maintenance schedule that involves flushing out these lines and getting this gunk out of there.
Yeah, often I think we've
any
all had
questions
that.
Before the next slide.
We've all had that situation where we've asked, when was the last time you cleaned your filter? And
Nope,
the answer
I think I have
was,
some
what
internet
filter?
issues here. I'm sorry,
Right,
I missed that.
Yeah, sorry, Shay. So I have a question here. Now, when you're flushing the lines after each irrigation event, right, how do you make sure that those chemicals don't get to your plants?
Oh, sure, yeah. So the ozone, hypochlorous acid, and chlorine, those three can be injected with or in line and be delivered to the plants. When you're flushing it, I meant that we get pure or just clean water through at the end of the irrigation event. So rather than having chemicals in there, then you just have clean water sort of a thing. If that's clear. Yeah.
Okay. All right. Yeah, good. Thank you. I just wanted to, get clear on that. Thank you.
Sure. Yeah. Cool. So building off of that, there's been a lot of learning done in specifically cannabis irrigation in this space. You know, the roots are in the basement is what I said here, which just means that a lot of these growers are coming from a more clandestine background where you're growing in your basement or a tent or a warehouse or something like that, where you don't really have access to these systems, or maybe the education isn't there on those systems. And those growers do very, very exceedingly well. They produce excellent crops. You know, they might have a hands-on approach where they go and feel the pots, pick them up one at a time. And they've developed this skill where they know, okay, I water at this point when it feels this light, let's say. And again, they produce amazing crops. Now, once you start to scale this up to a much larger facility, you know, you get handed the keys to 50,000 square feet. You can't be running around picking up pots all day, but it's also a thing that you can't really teach to somebody. It's because it takes many years to perfect that sort of a skill. So with that, a lot of growers now, I think 5 or 6 years ago, if you walked into a medicinal facility in Canada, for example, odds are you're going to see people watering by hand, having larger pots and that sort of a thing, and not very much in the way of an irrigation or fertigation system. This is absolutely changing. We see lots and lots of growers getting on board with drip irrigation and the benefits and the precision and the accuracy, the efficiency of these systems. So this is starting to be adopted far and wide. And with that, there's a lot of exciting opportunity to bring these practices from traditional horticulture into this space. And what we're looking at in the future, and I know Jane is very interested in this as well, is some sort of controller integration with moisture sensing technology that brings it all full circle. Because now if you've got a grower who's perfected this technique, if you've got a moisture sensor in there, he goes and picks up that pot, or they go and pick up that pot, and now they can say, all right, at 65% volumetric moisture content, that's when I irrigate. And now you can bring that perfected skill and attach numbers to it. So that's what we're looking forward to in the future. And I think that Jane is absolutely on board or focusing on this as well. Very exciting stuff. And now before I move on to the next slide, any more questions?
Yes, Shay, I just had one other question on that, right? And you mentioned it last week too, is that actually being able to measure the amount of water that comes back through the pot, right? Knowing whether or not you're effectively watering or not. And this water though that comes out, it's refiltered and used again. Is it wastewater? What happens with that?
A lot of facilities now are doing drain to waste, which does go and go into the municipal system or other, disposal methods. But we are starting to see a lot more legislation that is demanding recirculation. It's much more common in, larger greenhouse facilities to capture all the leachate, filter it, sterilize it, and then put a little bit more nutrients into it and then send it back out. So I think the shift is going to be towards this recirculation. Absolutely.
Yeah, and then this is kind of an out there question, right? Maybe not in your area of expertise, but if these are are indoor facilities and that are getting municipal water, are they getting a break because it's ag water, or are they paying the full municipal fee that I would pay for my tap water?
I think it's going to vary from municipality to municipality. Sorry. But yeah, we have seen very extreme cases where, for example, an area in remote British Columbia, they were actually bringing in truckloads of water. So they were paying a lot of money to water those crops. And then it becomes very pertinent to get the most use out of that water. So it's absolutely a focus. And I think you might see some facilities getting that break and others will not be.
Yeah. Interesting. Okay. Yeah. Something I'd want to find out before I started, I think.
Yeah, definitely.
Yeah.
Cool.
Okay, great. Thank you.
So this is just, the shifts in the cannabis crop management, what we've been seeing, kind of a snapshot of, where the industry is coming from and where it's heading in terms of general crop management. So in the past, especially in Canada, a lot of licenses were handed out that were per plant. And with that, if you get a license for 500 plants, you're going to want to grow those plants to be as large as possible, get the maximum amount of production per plant. This means you get very big pots, very high volumes of media, low planting density, and usually a peat-based media that can hold water for a long time, and you get large and frequent irrigation events. You can kind of see the pattern here. It's very, ups and downs and large, big rushes of water at once and hand watering. But now as things are shifting and the industry seems to be maturing, you see a lot more smaller pots with a higher planting density and more of a shift towards growing media like coconut coir and rock wool, which have very high porosity and drain very quickly. And this means you need to have smaller, more frequent irrigation events. And of course, the same problem, you can't be running around watering all your plants all day. So everyone's shifting towards this automated drip. And now the next stage as well is the benefits of pressure compensation are being adopted by the industry, which is very, very cool and exciting. And I know one question came up last week that was about specifically like how much do you water the crop or per plant or whatever. So there's a couple ways to break that down from a design standpoint. And what we tend to use is, depending on the growing method, because a lot of growers were using larger pots, moving to smaller pots, but there's still some that have excellent success with large pots. In those cases, you can kind of look at it as a per plant basis, and you tend to max out around half a gallon per day at the peak of production. But then when you get to more dense planting densities, it's better to look at it in a square foot or square meter basis, because at the end of flower, if you've seen cannabis crops in full production, the canopy kind of looks the same regardless of if you have one plant per square foot or one plant every 3 square feet, if that makes sense, because they kind of fill the space and make maximum use of it. So then if you look at the water use per square meter, then it tends to be 5 to 8 liters per square meter, forgive the metric. So I hope that answers that from last week. I know that came up, but
yeah, it certainly helps kind of give you some groundwork. And it's interesting too, because you're talking about the amount of water, and we can watch in our product sales what's happening, right? And it's interesting because you can see trends, in the old days, 4 years ago, 5 years ago, 2 gallon per hour octobubblers were a really big seller for us, right? We've 2s, 10s, 20s. And then we saw a shift to 20 gallon per hour octobubblers a few years after that. I haven't gotten this question in a long time, maybe 3 years, but people used to ask, hey, if I just take out all the flow restrictors, will it just flow water with no restriction, right? And this was a time when everybody wanted to put lots of water on. So it's kind of interesting to see the change. And boy, as far as a community being scientific and really studying this, your group, wins that hands down. I mean, they're really looking to what's going to work best and have the data and the ability to measure it. So it's cool.
Yeah, absolutely. We've got some trials going on right now, actually, with R&D specific to irrigation, where it's very exciting stuff. So, yeah, and that builds into this next piece, which, the industry is very much shifting towards this kind of low and slow, like more even irrigation practices throughout the day, which, unless there's any more questions related to irrigation, I'm going to pass that on to Patrick, where this all relates into HVAC management, because if you have these big spikes, it's not so good for your HVAC system as opposed to this low and slow, gentle hysteresis.
Right. Okay, great. Thank you, Shay. And welcome back, Patrick.
Thank you. All right, so a little bit of a repeat from what we did last week and what Shay has talked about, but HVAC, you have a contained space now. We're bringing in that water with irrigation, hopefully nice, low and slow. We need to bring that out mechanically, and that costs us money, but low and slow, nice and even, that's the optimal way for watering, to have it removed mechanically, because it keeps our demand very even, very consistent. So we talked about last week, which we'll review quickly in a second. Some of the balance, the different components that exist in the space and how you create a balance. Specifically last week, we talked about more of a static example. So this week we will go over 2 factors that increase the complexity in the environment. And it really underscores why quality mechanical equipment is key. In addition to the more efficient heat removal, you also get scaling to set points rather than operating around or orbiting set points, and they can handle a wider range of scenarios, which we will cover now, and you can see some of the value there. So this first example, this first slide, this is exactly the same as from last time, except for we've added the quantifier up top, and this is at the start of the flowering period. We'll get into the complexity there in a moment. So as a refresher from last week, we have our orange arrows pointing up. That represents heat being added to the space. So in that top left, we have a Gavita LED running, dropping photons like rain onto the plants. We're increasing the heat in the space. The plants are then getting irrigation, getting water. They're outputting the moisture, breathing that into the air. And then the blue arrows show which mechanical equipment draws down that moisture, and the orange arrow shows that the HVAC system is responsible for drawing down that heat. So this is at the, pardon the label actually, this is at the end of flower. So you can see that the plants are very large. It's the largest they'll be over the course of the whole cycle. And so they're putting out the most moisture they can. And so that's when Shay talks about peak irrigation. We're talking about the very end of the grow. If we jump to the next slide, Here we are. This one truly is the start of the flowering period. And so when the plants come into the flowering period at the very beginning, they're very small. They're, I mean, very, very, very small. They're almost not really prepared to handle the flowering experience. So we still have that heat coming in from the LEDs, but you can see that the moisture is reduced there. There isn't as much happening. So the dehumidifiers grayed out. Potentially, we might not need that dehumidifier. The HVAC system potentially could draw down that moisture, draw down that heat by itself. And then even as you can see, we have a humidifier that I've snuck in there. There's a potential, depending on your setup, you might have to add humidity at the beginning. And I know you might say, well, wasn't the whole point of using this larger system, this more quality system, so you don't have to have multiple mechanical pieces in the same room? And that is true. I think most growers would argue they would rather have to add moisture at the beginning of the grow, which is something you can do very easily. You can pipe it in and just have the moisture, rather than having a dehumidifier or other mechanical equipment in the space that will bring down moisture and produce heat. There's a lot more complexity there. So keeping the quality at the very end of the grow, when the most moisture is present in the space, where it's the most difficult to control, is the primary goal. And so sometimes that means we might have to have a tiny humidifier at the beginning for the first little period. But that is a takeaway that we will certainly enjoy versus having too much humidity and the potential for disease pressure at the end. So the changes over the course of the beginning to the end is the first example of some complexity. This is a second example of some complexity that can happen that is frequently seen in controlled environment agriculture. So this explanation is broken across 2 slides. So hold the questions for just a moment. But this is a typical 24-hour cycle for an indoor space. You'll see the lights come on the bottom left, and you progress over through the right. The bottom line in orange, that is our heat. And the top line, that is the relative humidity as it goes through the cycle. So you can see we have our day cycle on our left, where the humidity is bouncing more. We then have an event happen in the middle. As you can see, it's labeled as the lights off event. And then we have our night period afterwards. So this lights off event is a very common thing that will happen in most of these environments that isn't common in outdoor growing, and then in greenhouses is less common. So it's something we want to focus on. So if we jump to the next slide, this will go into detail a bit here. So when we discuss humidity, generally the term that is used is relative humidity. So what is it relative to? Well, in the applications of controlled environment agriculture, it's temperature. If you put one of these growing spaces in an airplane or something like that, we can talk about pressure, but haven't seen one of those before. Generally they're on the ground, so we'll focus mainly on temperature here. So what happens is the space is very warm when all the lights are there. There's all that heat being added to the space. We're good. You can imagine the capacity of the air, the amount of moisture it can hold. It's very large. We have a very big bucket hidden amongst our air. Once the lights turn off, the ability for the air to hold moisture, it changes, it shrinks down. That's how you can get, for instance, dew in the morning grass. It's a cold morning. So that bucket is shrinking once the lights come off. So I've taken the graph from the last slide and I've put it here side by side so you can see on top and on bottom, put them next to each other. That relative humidity is the exact same time that the temperature drops off. And so they're related. Obviously, the plants are still adding moisture to the space. So some of that peak is still from the plants themselves, but a lot of it is from the change in temperature. And so that's why one of the reasons why having quality equipment is important. And actually, Shay, if you can click one more, I have a visual down below. I'm a very visual person. So this is a perfect example when we talk about the change in temperature. You can imagine that ball in the middle, that's the water. You're 80% humidity, relative humidity, pardon me, at 70 degrees. And as the air is able to expand, the moisture does not. So the relative humidity changes with that temperature. And of course, we care about the conditions that plants grow in. So it's not a linear relationship, but in the zone where plants grow, 1 degree temperature change usually is a 1.5 to 2% relative humidity change. So it will spike more quickly than your temperature changes. So this is a very common issue. It is something that happens frequently. If you have all of your lights turned off at the same time, you have a massive temperature change. So some of the things that we recommend growers do in order to address this issue, well, a couple things. One, you can schedule your irrigation on the front end so that you schedule and make sure that your moisture isn't entering the space. Since you know the lights are going to turn off at the same time every day, you know when the spike is coming, you can pre-prepare beforehand. So the first thing you can do is you can change how much moisture is coming into the space. Second thing you can do, you can start your mechanical equipment early. to bring that humidity down before it becomes an issue. And the third thing that you can do that is very common is you can schedule your lights to either dim. So the Gavita LED is capable of dimming. So that way you'll step down in heat as you go. Or you can have individual bays or every other bay, some sort of pattern where lights turn off in sequence so that you can step down at a rate that your mechanical system can still recover and pull down. So you'll bump up artificially, pull that down, bump up, pull that down, and then you're good to go, rather than having everything happen at once and potentially increasing your risk for disease and other blights. So that's a perfect place to stop there, but it really shows the value of having quality mechanical equipment. There's an increased upfront cost, but there's a lot of complexity and a lot of different things you have to juggle at the same time. So having a single mechanical system that can do all of those different functions at the same time by itself is extremely valuable, rather than trying to rely on multiple systems to be balanced while the balance is also changing naturally in the background. There's a lot of complexity. So really shows the value of that complicated quality mechanical equipment.
Yeah, and so those management practices, again, are really to help with that relative humidity spike that's going to occur when those lights go off.
Yes, exactly.
Yeah. So somebody was asking about, that there's biofilms in the HVAC too, right?
Yes.
Is that the same type of biofilm that's in the irrigation, or is it something else? And what do we do about that?
So Shay would be a better person to answer about the irrigation biofilm, but I'm going to assume it may be similar, probably different just because of air versus being underwater. But no, biofilm buildup in the HVAC system and the filters is a very big issue. You can imagine those filters, they catch everything. If that's biofilm, bacteria type stuff, it's excellent. If you have any nutrients, any moisture, you can just proliferate, there we go, third time's the charm, and just spread it through your system. So making sure to clean ductwork, it's same sort of focus as with irrigation lines. You run the same risk of disease pressure. It's just coming from the air, coming from your mechanical systems, rather than coming from your liquids, coming from your nutrients.
Yeah. Okay. All right. Great. And Shay, you think it's the same? Is it the same biofilm in both?
Well, I think biofilm is kind of a general term, and then I think most like no two are going to be the same flavor to make it really gross, but it's because it's really an accumulation of many different species, and they can range. The danger there can be their plant pathogens and sometimes even human pathogens in there. So. Yeah, they're going to be different, but same idea where, it's a group of different organisms clinging to things. Yeah.
Yeah. Okay, good. Thank you. And Patrick, that step up, step down process that you discussed, can people use that in a greenhouse environment too, where they're not necessarily using lights or as many lights?
Yeah, certainly. So I guess if you have a humidity spike due to temperature change, then certainly it could be something that solves that problem. Generally due to the fact that you have more contact with external air, depends on the type of greenhouse, but generally the indoor environments, you recirculate the air more, where greenhouses, there tends to be across the board more venting that goes on. So because of that, because of the closed nature of the indoor environment, and because most of the heat is coming from the lights rather than a combination of the lights and the sun, you could use that in a greenhouse. I think it's less critical than if it's in an enclosed space, and it certainly matters about what time of year and what your altitude is, just because if the sun drops off quickly, then certainly it could be an issue that you see, and it could be something you could use to combat.
Yeah. Okay, great. Thank you. So, okay, I think we've covered all the material now. I know we caught the questions as they went in, and I got to tell you guys, you were fantastic last week and equally fantastic this week. So once again, I want to say thank you for coming and helping us out. Shay, you have some summary that you want to go over?
It's okay. I think they can just read through it. Yeah.
So again, yeah, thank you guys. Thanks everybody for tuning in today. I really appreciate it. You know, it's a commitment of time, and we take that seriously, and we want to deliver you some really great information and quality education. We hope we're hitting that mark. And if we're not, or if we are, please let me know. Either way, we're always looking to improve. We've got, of course, all our past sessions on the Jane's USA website. And you can search irrigation or Jane Irrigation on Apple, Google, and other podcast hosts, and listen to these as well. So if it's easier to listen, we want to invite you to do that. Again, everyone from Hawthorne, Patrick, Shay, Rebecca, thank you guys so much. Really appreciate it. And hopefully we'll be seeing you all soon. Thank you.
Awesome. Thank you very much, Richard.
Thank you, Richard.
All right, thank you.